For this unit, we're going to look at Graph Basics by Ignacio and Joe. And first, we're going to take a look at how the motion of a ball going up and down a slope will affect a graph. Look over here. So we have a ball rolling down a slope. It is accelerating down with the force of gravity. So therefore, it'll have an accelerating, increasing velocity versus time graph. When we look at a ball rolling up a slope, it'll start out with a strong push, but then it'll start to slow down as it goes up, resulting in a concave down velocity versus time graph. So just pen out real quick. See the difference between rolling down versus rolling up. Alright, now we're going to just review some graph basics. So it's important to know your x-axis versus your y-axis. Pretty simple. X-axis is the horizontal axis where your x points will be. Y-axis is vertical, where your vertical points would be. And we use slope a lot. To calculate slope, you go rise over run, so it's the change in y over the change in x. So you'd run up 3 over 2, for example, to find your slope between points. And also 4 different types of signs, you could say, that a slope could be. Here you could see it's negative because if you're walking from the left to the right, you'd be walking downward. Positive, walking from the left to the right, you'd be going up. 0, not going up or down. And undefined, you just fall right off if you were walking. Review those. Alright, position, velocity, acceleration are the 3 different types of graphs that we graph. It's important to memorize this box because it's important to know this order: position, velocity, acceleration. As we can pan over here, you can see that position could be y, velocity is the derivative of y, and acceleration is the derivative of velocity. You see right there. We'll jump into what a derivative is real quick. Here's the formal definition, but we'll go back into it some more on the next page. A derivative is the slope of the tangent line to the graph. Tangent line is just basically, right here. If I were to draw a line that continues with the slope right here, that's a tangent line. So basically you graph the tangent lines. You're graphing a graph of the slope of the line. And so we can get from position to the velocity to acceleration using our derivatives and slopes. We'll just look over here real quick for some good examples. So up here we have our position, which looks like the graph that I just showed you, our velocity, and our acceleration. So here we have increasing concave up position graph. And if you were to take the derivative, if you were to graph the slope of each point, you'd get this. And then from there, if you were to graph the slope of that, you would get acceleration. And then also, we can also go backwards using our integrals, which is the area under the curve. So you can look here, as the area under this line gets bigger, our graph of the velocity will get higher and higher, because as we move from left to right, the area under the acceleration curve is getting bigger. Therefore, the velocity line will increase more. And same goes for the position graph. As the velocity area from left to right increases, this line will increase. So as you can see, derivatives play a big part, and it's all based on the slope of the line and the area underneath the curve. So it is important, once again, to memorize this table with these derivatives and keep getting your derivative practice in. Once again, Graph Basics by Ignacio and Joe. Gracias.